All right, moving on to setup now. Now, the very first thing I usually address when I start powering the system up for the first time is the speed control, which we've already covered. So we've set our high and low stick travel, so the ESC knows where full throttle and low throttle is. So that's already done. We've checked the direction of rotation of the motor, that's correct and has been reversed, so it works the right way. By the way, one of the things I did off camera, I added a little bit of a heat shrink to this antenna mount because my antennas were kind of falling out of it. So do go ahead and do that as just a preventative measure so the antennas don't come flying out the sides. But next thing we need to do, and the first most important thing, at least when it comes to the rotor head, is leveling the swash plate. Now, I did go ahead and program my servos, so I used the template that SAB gave us to position the front cyclic servo. Since they're on an angle, it's not quite 90 degrees, and I set the elevator servo at 90 degrees. So I might get lucky. My swash should be pretty darn close to level, if not perfectly level. We'll see. Every now and then you get it dead right on the bench, but we're going to measure that in a few different ways, and I'm actually going to show you a few ways to level your swash, some more expensive, some less expensive ways to have at it. So let's dig into leveling our swash plate. I probably should have chosen quieter servos for this build. Torx are fantastic servos. They do make a little bit of noise, so I'll apologize for any sort of beeping and buzzing you hear as we level the swash here once I power this thing up. Still got the blades off at this point. Again, you verified your throttle cut and all that works. Safety, safety, safety. We're going to talk about it multiple times throughout the video. I've got my pack charged and ready to go. But we're going to talk about methods to level the swash plate. The first is using a swash leveler. So this is not the correct swash leveler for this helicopter. This is another one from SAB. This is for the previous generation of RAW's main shaft. So this would actually sit underneath the swash plate and go under the main shaft, or go around the main shaft under the swash plate right here. And then these three little tabs would sit under the screws that go into the swash plate, and you make sure that they're all equidistant. So this is one method, is purchasing the particular manufacturer's swash leveler. Here's one from XL Power, meant for 15mm motor shafts. The nice one about this SAB one is you don't have to take the rotor head off to use it. You just lift up your collective, pop this underneath, and then go ahead and level your swash. So that's option one. Option two, and this is the one I'm ultimately going to use. This is a swash leveler that you can purchase online. It's essentially just a 3D printed clamp that just pushes onto the main shaft, and there's a threaded screw that comes through here. Let me get you a close up. So there are multiple holes along, so you can adjust where the screw goes down as it clips onto the main shaft, and you can see there's a bolt through there that you can adjust up and down, and it's just a matter of clipping it onto the main shaft and then kind of rocking it back and forth, or using the a driver to adjust the height of the screw, and then you're just moving the rotor head around to check the various heights. And sometimes you have to trim it, like in this case, or go around either way to avoid the alignment guide here. All right, but I'm going to show you the zip tie method. It is by far the cheapest and easiest, and it's this simple. So you've probably definitely heard somebody talking about it at some point. And I'm using these orange zip ties so they show up a little better. So I'm just going to wrap the main shaft under the rotor head in a zip tie as tight as I can. And I'm going to do it in a gap here as tight as I can. So let me spin that around so you can see. So there it is, just a zip tie right under the rotor head here. Actually, I'm going to get it a little lower so it's not impacted by the follower arms here as things go. And there we go, zip tie there. I'm going to rotate it around to where it meets our alignment pin guide, which will be in different spots on different helicopters, and I'm gonna cut it to length at that point. There we go. So now I can rotate it 360 degrees around. Now here's the easy part. We're going to take the piece of the zip tie we cut off and make it a little bit shorter. So there you go, just a rectangular, piece of the zip tie. Doesn't even need to be this long. I'm gonna cut it nice and square and flat, and I'm gonna position it right over one of the extensions from the swash plate that our ball's attached to. And what I'm going to do is I'm going to take a little bit of CA, and I'm terrible with things like CA, so I'm going to put a little paper towel underneath in case I drip, and I'm going to put a drop of CA on the end of the zip tie. Yeah, so you can see I'm already dripping. So drop of CA there, and then I'm going to take this piece of zip tie, and I'm going to rest it right on top against that CA and against the top of the swash plate there. So it's resting right here on this ball. And I'm going to take some CA kicker. See, this is just tentatively held in place. And you don't have to get this perfect because you can adjust it later. You just got to get it close. So get these held together. Try not to get CA on your fingers. Back over the piece. And I'm going to take my CA kicker and just spray some in there. Okay, with our kicker sprayed in there, we'll just let that sit for a second and clean up all the kicker spray that's all over the place in here. So now we're going to power the helicopter up, and I'm going to apologize now that it's going to get loud. Okay, now we're going to go into whatever mode your flybarless has that will let you set your swash plate at the level position. So, in case of the Neo, you're going into your advanced trim menu. And now, what I need to do is get this zip tie a little higher, even if I have to trim it a little, because I didn't quite trim it enough. I can always lower it, but you can only, or I can always raise it rather, but you can only, at some point you run into the top of the swash. Okay, so I'm now going to lower this until it touches this top of the swash plate, because I'm going to call my elevator servo the dominant servo here. We're going to call that one level, because it's probably the one I was most accurately at 90 degrees for. So I'm just going to get this till there's just a sliver of air, and I can rock it back and forth and not hit it. So right now, right here is just a hair above this part of the swash plate. So we're going to call that our level point right there. So now we're going to rotate this around to the back side, which is servo 2. And I'm going to go to the servo 2 and raise it. I'm off just a little bit. Oh, so few points. And I want to be able to get this past without hitting. And I'm going to go back to my original point and check. That looks good. Looks like I'm hitting a little bit here, so I went a little too far. So I'll reduce that. Okay, that's no longer hitting anymore. And that was only like 5 points off the center. This side here is definitely hitting a fair amount. That's servo 3. All right. So now I'm going to check all 3 one more time with our little zip tie guide to make sure they're all at the same point. And sometimes adjusting one side will mean another side shifts a little, but that's pretty dang good all the way around. Okay, now we're going to go ahead and just cut the zip tie. We're done. Our swash is level. There is your 75-cent swash level. Sorry about the sunlight coming in here. It's been in and out today. All right, we're going to check it again with this other method, this little clip-on method. So I'm going to go ahead and push that on. I'm going to slide this guy down till the screw is really close, and then I'm just going to take a driver. Actually going to rotate this a little more so I can have access to it with the driver. Right now the blade grip arm's kind of in the way. And I'm just going to give that a few turns until the screw just barely, almost, but doesn't come into contact with the swash plate. Looks like I got another turn in there. That one, I don't know if you can hear that, but it's scratching. Okay, so now I'm set for no noise. That's perfect. I'm gonna have to go round back the other way to get to the other side on this one because this arm is long. And there we go. So versus the zip tie method, I only made 1 point of tweak with this. Maybe slightly more accurate, honestly, I don't know, but that 1 point of adjustment is probably not enough to make any kind of meaningful amount in flight or anything that you would have noticed. So our swash plate is now dead level. So that's mid-stick. A couple of things you want to check. that this follower arm right here, and it should just kind of automatically work this way based on the geometry of setting the length of your servo arms, should both look at 90 degrees, and in my case at 0 pitch, and they do. So that means we have a solid mechanical setup. So you want swash plate level, servos at the 90 degree mark. You want these follower arms to be square, or sorry, at a right angle, so level essentially. And then you're ready to move into pitch. If any of these things is not correct, your servo's not at 90 degrees, or in the case of these front servos, level to the ground, parallel to the ground. So that's situation number one that has to be true. Servos at 90 degrees. Then you have to get your swash plate level while your servos are at 90 degrees. Then your follower arms need to be level, parallel with the ground as well. And you don't need to put a level on them. You can just eyeball that. That's fine. Now we're able to adjust our main blade links to set 0 pitch. So that's where we're going to go next. And to do that, we're going to have to go ahead and bolt our blades on. Whoa. Wow. These blades are fluorescent. Wow. Even more so out of the package. Yowzers. You checked your throttle cut was off, right? You want to be really safe. Disable your ESC in some fashion. All right, we are going to need to use blade washers here. The cool thing is SAB has created these such that you push them into the grip, these little nibs in them, and they stay. So no fuss, no muss. Make sure you install the blades correctly so that the leading edge here, it will rotate clockwise, which is typical of most, certainly not all helicopters. And then line up the hole, drop the bolt through, grab your lock nut, no Loctite on the bolt, because this is a plastic lock nut. You can hear the servos complaining, that's just from the weight of the blade, which is not overly heavy or anything, they just are working against that load. And we're going to tighten our blades such that, and you kind of get used to what the feel is. It'll hold in place if you turn the helicopter sideways, but if you sort of do a little like lower it for a foot and stop, the blade will pitch down to about a 30-degree angle. And I need to move the body of this helicopter such that I can rotate the blades around my shop without hitting anything, including cameras, and also is level and not sitting on top of any washers and things on my bench. There we go, we're good there. And if I duck, it'll go over my head there. Now we do this because when we rotate to check the pitch on both blades, we do not want to move the helicopter because our pitch gauge is very sensitive, and even slight variations in the pitch of the table. Now this table's pretty damn level, but any variations from one spot on the table to another will affect the pitch as well, because we're measuring, finite degrees. You don't want the heli to move once you get it in blades. Still no tail blades on the helicopter. That'll be the last thing I put on when we set tail pitch in a second. I'll use them as a reference. I tend to over tighten and then work my way back, and I just know by feel where I like my blades to be. And then you also want to make sure they're the same as the other one. It's very important that blades be equal tightness. All right, there we go. Okay, so we now are at a position where we're going to set the head such that it is in line with the body of the helicopter. And then we're going to check our blades are also that way. And we do that by putting them over the tail boom. We'll rotate and check the other side here. I'm dead parallel with the mainframe. Blades looking good. Be quiet, servos. All right, now, digital pitch gauge. This is one by RC Logger, which unfortunately are no longer made. You can sometimes find them on eBay, however. But they all work in similar fashion, whether you have a variety of different ones. The first thing you need to do is tell it what level is. And traditionally, the flattest spot on a helicopter is the motor. And we just need to set a 0. Honestly, if this 0 isn't perfect, not the end of the world. What matters is that we use this, what we're calling center, to set both blades to match each other, because that's the most important thing. So most pitch gauges you will be able to put across the motor, and then they have a way to 0. In the case of the RC Logger, there's a 0 button you hold down. And I stop talking because I don't even want to breathe because it's that sensitive. And there we go. Now we have a pitch gauge set to 0 degrees, and I'm going to slide it onto the chord of the blade. Now here's where it gets interesting. If you're Nick Maxwell, you believe that, and I'm not saying anyone's right or wrong, you should set your pitch towards the end of the blade because that's the part of the helicopter where most of the control happens. And I'm inclined to believe he's right, so I tend to leave my pitch gauge a little further out. There are those that say you should set it closer into the root because this part of the blade there's less flex and it's more accurate. Honestly, I think both work pretty well and get you in the ballpark. And what we're working on here is to make sure our tracking is correct. So as the blades spin around, the area that this blade spins through is exactly the same as the area that this blade spins through. And if they're off in pitch from each other, you'll actually be able to bring the helicopter into a hover right at eye level, and you will see between the tips of the blades this gap. Now that means your tracking is off. You want there to be no gap. You want the tips of both blades to pass through the same air. The reason for that is when there is a gap there, it actually can lead to pretty excessive vibration that can upset your fly release unit, and it makes everything fly less well. So definitely worth putting in the time to get this right. Now, what this pitch gauge says now, it doesn't matter, right? What I'm saying is it doesn't matter if it doesn't say 0 right here because the adjustment on these links is approximate. There's a lot of variables at play, especially as these blade grip arms attach. Maybe you bolted them in slightly off. Doesn't matter. What matters is that we set this to 0. So I'm going to grab an awl and use it to adjust to the turnbuckle that affects this blade. So this blade is in this blade grip arm, which is attached to this, is in this blade grip, attached to this blade grip arm, attached to this turnbuckle. So right now the pitch gauge, and I know you can't see it, is reading -1 degree almost perfectly. So there's a little hole in this turnbuckle, and I'm just going to turn it in one direction. It's stiff, there it goes. Whoops. And you might pop a blade grip off, in which case I have a fix for that too. Just like I did, so don't let that stress you out. Sometimes these things are just stiff, especially when they're new. And there is a tool to stop that made by X-Guard, and it looks like this. And essentially what it is a system that you can slide onto each ball link, and this will hold them level to each other so they're parallel, and allow me to adjust the turnbuckle here. So the thing is, every time you touch this, the rotor head moves a little bit. So keep checking to make sure it's in line with the body of the helicopter. We're now at -0.5 degrees, so we were going the correct way, which I think was towards myself. Now I forgot. So now I'm going to hold this tool from X-Guard while I turn the turnbuckle. Okay, again, keep checking the rotor head is in line with the body. All right, getting closer. It's definitely this direction I need to go. All right, let's see how we are now. -0.4 degrees, so we want to move this up to positive. We want to get this at 0.0 degrees, ideally. All right, this is -0.1 degrees, getting real close. So this will be a small adjustment. I'll take these off as well. When you get real close, sometimes you got to take these off, give them a little wiggle, see where it settles. Still at +0.1. 0.0. You're just going to have to trust me on that. All right, now we've got one blade grip set. We now need to flip it and do the same on the other side. So we do not want to disturb the position of the helicopter. So gently remove the pitch gauge. Don't shut it off because you need it to retain that level information. I'm going to duck out from under that blade. Ideally, if I weren't filming, I might move this to the kitchen table or somewhere there's loads of room around it. And I'm going to bring this to about the same position it was in on the other blade. Ooh! 0.2. So we're already real close on this side. Now, still this blade grip on this side because the other one is now rotated in front of me. And was that negative or positive? That is positive, which I think means I need to rotate this way. But it doesn't matter if you know or don't know which way you're supposed to rotate. Just rotate one direction, see what happens. And of course, what happens is you pop off the link. Okay, let's get this back parallel, see what we got. Wrong way. Coming back the other way. Check that we're parallel. 0.0. So fussing back and forth, but we're in good shape. All right, we are not going to take the pitch gauge off because now, depending on your flybar list, you're going to have to set some additional pitches or verify them. So I'm going to get myself out of swash level mode, and I'm going to calibrate my pitch gauge to 8 degrees, which is what the V-bar wants me to do. 7.9, 8.0 on the nose. Okay, next thing I'm going to do is set a positive and negative pitch. So I'm going to start with negative. And I'm going to start this helicopter at 12.5 degrees. That's my favorite starting point. You set this where you want. It immediately went to 14 degrees of pitch, so there's obviously tons available here. Okay, 86. Pay attention to that number. Now we're going to positive pitch. All right, positive pitch. Let's take it right to 86. Beautiful, 12.4 degrees. So, while these numbers don't need to be exact in the V-bar, it's nice when they're your positive and negative pitch are within a point of each other. It means that you have very equal throw top and bottom, and that your swash blade is dead at the center of travel, which is a great indication that your setup is complete and accurate. Okay, that's it. So basically all you do in V-bar is set your blades to 0, calibrate, like let the flybarless unit know where 8 degrees is, and then set your maximum positive and negative, in my case, 12.5 degrees of pitch. All right, last thing to do is set up the tail. I'm going to reorient the helicopter so you can see that, and we're also going to bolt some tail blades on. Looking at the manual here, they do in fact want you to use washers on the tail. So it goes on the bolt side, and you'll just put a little washer on the bolt. Again, no Loctite here because that is a nylon lock nut. Okay, we're going to go to the overhead for the tail portion and see if we can make the tail visible. But first, I'm going to bolt the tail blades on where I can reach the helicopter better before I spin it around to where you can see it. So I'll be right back with the tail blades on. Okay, I'm coming in at a weird angle here because I'm trying to show you as much as possible with the tail. So things to note about the way the tail is bolted on. Make sure the bolt enters from the outside and the nut is on the inside closest to the tail boom. So nuts both go on the inside. If your blade grips go otherwise, there's a little hexagonal slot here to receive the nut. If that is on this outside, something's wrong. Your blade grip is flipped around the wrong way. So do check that out. So, okay, first thing we're going to do is make sure we have the right control throw direction before we set any throws. So we're going to look at the top blade and we're going to look at the trailing edge of the top blade. So the trailing edge is the thinnest edge, the thicker edge is the leading. And we're going to make sure it points straight up. Now, when we take our tail control and move it, the direction of the trailing edge should move the same as the stick. So if I go left, it should go left. If I go right, it should go right. And it does. Left, right, left, right, left, right. So our control throws are correct. Now we're going to check our gyro in a second, which means as I move the tail boom this way, the trailing edge should come this way as well. As I move the tail boom that way, the trailing edge should go that way. So let's check that out. It's really hard to see because we haven't programmed our full throws. So let's go ahead and program our full tail throws first, and then we'll be able to see the gyro correction better. Because right now all we've tested are our control throws, direct stick to input. We also need to see that the gyro will correct the helicopter in the correct way. So, case of the V-bar, move the stick to the left, and then I'm going to adjust the throw to the maximum amount, and then I'm going to do the same on the right. And for my max throw, I don't want to be too far to the top that it binds. And you can kind of hear that in the servo. It changes tone when it's binding, but it can go that far. And then same thing on the right. Now, if your throw measurements for your left and your right are not fairly close, within 5 to max 10 points of each other, I would look at recentering your servo horn and then trying again. So, in fact, mine are 62 and 78 right now, which to me is a little low. I'd actually like those numbers both to be higher. So I'm going to try moving the ball on the servo horn further in, closer to the servo spline, which will give me more control resolution. And then I also need to go a little more towards the left side so that I get more equal throws. So I'm going to go ahead and do that now. Done some tweaking, and I've moved the servo to the inner hole on the SAB servo horn, and I have much higher travel numbers. I'm now in the high 80s, low 90s, and the numbers are much closer together because I repositioned the servo horn. Now for travel, you want to go till just before it hits the tail rotor there, and just before it hits the inside there. And this tail servo is noisy as all get out, but I assure you it's not binding. And we're just going to look at the push rod, make sure everything looks good, and it does. Great. All right. With that, the last thing we have to check is gyro directions. Now that I have more throw, you should be able to see this. So as I move the tail this way, the trailing edge of the top blade should come towards the boom. And as I move the tail this way, the trailing edge should go away from the boom. So it follows the direction, and you can see if I go slow here, it does. So if I come this way, it'll come towards the boom, and it does. If I go this way, it goes away from the boom. So that's my gyro corrections on the tail. It's going to be a little tricky to move in here, but we're going to see if I can show you the gyro corrections on the head, which is the last piece to check. Okay, so gyro corrections on the head. The swash plate should want to the swash plate should want to stay level no matter what I do with the body of the helicopter. So you can see that as I twist, the swash plate stays level. And if I go forwards and backwards, it should do the same thing. If it doesn't, go back to your flybarless setup and find your gyro correction menu and check it. All right. So with that, we've set our zero pitch. We checked our gyro corrections on the head. We set our positive and negative pitch, as well as did any calibration pitch that your flybarless unit requires. We checked our tail throw direction to make sure it's going left and right as we input from the stick. We also then verified our gyro correction. We set our tail throw, so maximum left, maximum right tail throw, so the flybarless knows where the limits are. The only thing left to check on this helicopter is the center of gravity. Now, what I mean by that, and to do this, we're going to have to actually go ahead and put the canopy on, so let's do that. Just check your canopy, make sure that the poles are in, that you're seated in that front clip, that you're either side of the alignment guide there as well. The funny thing about using this battery tray that connects is in order to test the center of gravity, I will have to power the helicopter up, which means it's going to buzz throughout this. So I'm going to give you a demo without the flight pack in it, and then I'll show it to you with the flight pack in it. So you will need your flight battery installed in order to set the center of gravity. So basically everything that's going to be on the helicopter needs to be on the helicopter. If you're adding a backup capacitor, that needs to be on the helicopter as well. And sorry, with the helicopter in the frame, it's going to focus on that. So we're going to grab the helicopter by the main rotor, just like this. And we're going to keep the blades up and down, and then we're going to let go. And obviously there's no battery in here, so it's tail heavy. The tail will fall every time. Now you can check this from both directions because the one-way bearings will alter this as well. But if I let go, same thing, tail's going to fall because obviously there's no flight battery in it. But that's how you check it. Pick it up and hold it by the blades up and down this way, and then see if the tail raises or falls, and then you know if you're nose or tail heavy. All right, I'm going to triple check that throttle cut is engaged. It is, and I'm going to power this up. Okay, now I've got my flight battery installed, and you don't have to be powered up. I do because I'm using the built-in battery tray plugs. Ugh. And we're going to let this thing go. I'm going to try and get it to go one way. All right, so in this direction, it's good. But again, the one-way bearing will give it some drag. So we always check it from both directions because you can never remember for sure which is good. I got to get out of the way of my workshop here. And this says I'm still a little tail heavy. So that means I need to move my battery forwards in the tray. So I'm going to go ahead and pull the tray. So In order to get more nose weight, it's as simple as undoing the Velcro straps and moving my battery further forward. So I'm going to go ahead and do that now. I've gone ahead and moved my battery, so the furthest forward it'll go, but don't worry, if it's still tail heavy, I have an ace up my sleeve. And, oops, so I knocked stuff down off the shelf. Check it out. Perfect. Maybe a skosh tail heavy. Yeah, tiny bit tail heavy, but there's good news there. I'm going to shut this off so it gets quiet. So that's very close. So we're now pretty darn close on our center of gravity, but here's my ace in the hole. I have a backup capacitor that I'm planning on installing, and I always save this to last because I want to see if I can get the center of gravity right with the tray. And if I can't, and I need a little more nose or tail weight, this is a nice thing to have to add forward or back and find a location for. So now I know I should probably put this somewhere forward, and if the helicopter becomes too nose heavy, I can always slide it backwards. So I'm gonna figure out a place to put this. I'll let you know what I decide on. All right, we got the battery capacitor mounted at this point. It's actually under the ESC tray. So it goes ESC, carbon fiber plate, capacitor backup, and then the motor wires passing underneath. And then that's all zip tied as one bundle. A little bit of double-sided tape on top of the capacitor backup, and it does fit in there sideways. You do need to use a small enough one. This is a really small 25 farad one that fits in there nicely. So all that's left to do is slide the battery pack back in, radio is still on, throttle cut's on, and give it a try and see how it bounces. Let's see what happens. All right, let's crank it up. So in this direction, all holding wherever I leave it. Flip it the other way just to check. All right, rock solid in. Boy, it's hard to not hit stuff in this shop. There we go. Servos are quiet. All right, with that, I'm Nick Wisdom with HeliDirect. Thanks so much for watching this build video series. Any questions on the Goblin Pro, definitely hit us up. Any questions on building any model, for that matter, definitely hit us up. Hope this video helped you in some way or gave you some confidence to tackle the build yourself. Happy flying, folks.